Welcome back. I hope you enjoyed doing that lab. Now we want to take a look at our results and make sure that we are correctly interpreting the results that we saw. So if you turn in your lab sheet again that you just have to question number 10. That was the big question where we were coming up with the big list of who was the highest out of all 5 of these metals that we tested. And so let's take a look at who we got for the first one. Okay, well, I'm not going to be able to do this very interactive since I'm actually not here, so I'm going to assume that if I asked you who was the highest one on the list, who was top dog, you all had magnesium. Yeah, good, that's right. Okay, so out of all these metals, magnesium was the highest on the list. In all the reactions, that always ended up in the couple because it was highest on the list. Okay, now next, hopefully you ended up with zinc being the next highest on the list, and followed by lead, and then copper, and then the lowest guy on the totem pole was silver. So any compound, any couple that silver was in, anybody else comes along, it's going to kick the silver out and the silver got replaced. Now we want to see if these results are consistent with other people's results. So you should have just received a copy of this goldenrod colored sheet, and you want to turn to the side where it says activity series, because that's essentially what we've come up with here. This list of who is more reactive than who is what's called the activity series in chemistry. So we want to see if we're consistent. So we've got magnesium at the top. If you look on this sheet here, you'll see all about midway down, there's magnesium. Now we have zinc below magnesium, and if you go down a couple, you'll see, yep, zinc is lower than magnesium. Keep going down, lead's below that. Well, let's go down, we've got to go down a ways, but eventually there is lead. It is definitely below all those other two. And then copper, yep, that's below. And silver, that's below copper. So yes, our results are consistent with what we're seeing on this sheet. Okay, now this is another handy-dandy handout that you'll get to use on all future tests and quizzes, just like your comp-decomp cheat sheet. So put them all on a place along with your periodic table that you can use these all the time. Now you can use this sheet to make predictions without actually having to do the experiment. So what you're going to be doing in your homework is doing single replacement reactions, but you won't actually have the lab to do. And you want to see, is it going to react or not? So let's say, for example, that the question said, if I have some strontium fluoride and I want to react that with, let's say, zinc, and we want to finish this. Well, don't automatically switch them, because as we've seen, just because you make things together doesn't mean they're going to react or not. So what I need to do is check out this activity series to see who is higher than who. Now in this case, I look at my lone guy. The lone guy is a metal, so that means I want to compare it with the metal that's in the compound. So we find zinc on the list, and we find strontium on the list, and we see that strontium is higher than zinc. Okay, so since strontium is higher on the zinc, that means the chlorine would rather be with the strontium. Well, chlorine is already with the strontium. So whenever it's bonded with the one that's higher to begin with, that is going to be a no reaction. Okay, so don't automatically switch them. You might get no reactions. Now, of course, if the zinc was higher, then yes, I would go ahead and switch them and balance my equation. Let's take a look at another example. Let's say, again, that we started with strontium chloride, but this time, let's say that we brought some bromine along. And now bromine's also diatomic. Here it's the element bromine, so I'll put the Br2 there. And I want to see, are these going to react? Well, in this case, I look at my lone element. In this case, my lone element is the non-metal. It's the one that's going to have the negative charge. So I'm going to compare the bromine to the chlorine in this case and see if they're going to switch or not. Now, when you look on your yellow sheet that you have, you'll notice there are 2 columns. There's one column for metals, one column for non-metals. You should always be comparing 2 things in the same column. So we had, in the first one there, we had strontium and zinc. They're in the same column, so we're good. In this column, we're comparing bromine to chlorine. Now we can see that chlorine is higher, so in this case, again, this is a no reaction because the strontium is already with the higher one. So this one also would be a no reaction, so it makes life kind of easy in that case. So we need to check. Obviously, if it would have been the other way around, if we had had the strontium already with the bromine to start with, And if the chlorine had come along, well, this time we would look and see, yeah, the chlorine is higher on the list. Strontium would rather be with the chlorine, so they do react. So we will go ahead and switch. Now, because strontium is +2 and chloride's -1, my formula is going to be SrCl2. And then the bromine is going to be replaced, so it's by itself when we're done. It is diatonic, so it'll be Br2. And then the last thing we want to do is just make sure that everything is balanced. You always want to write complete balanced equations. And in this case, it works out balanced as is. Okay? So when you do your homework tonight, when you go to switch them, look first at this sheet. You need to compare who is higher than who to see if you're going to switch them or not. Other than that, it's pretty easy. It's just a matter of writing formulas and balancing. So have fun, good luck, and I will see you tomorrow with your homework finished, and hopefully you'll have done it all correctly and easily, and we'll be ready to move on from there.